Now children, let us look at how the atomic radius vary across a period. As you can see, we already discussed how the effective nuclear charge increase, or in other words, that tells you how well these valence electrons are attracted towards the nucleus. Now let's just consider the lithium atom. So you have the lithium, so here it's a nucleus. So on the so let's consider the first energy level 2 electrons, second energy level 1 electron. So basically what we are discussing here, these electrons, how well, like the attraction towards the nucleus. Now as you can see here, as the effective nuclear charge increase, the attraction of this valence electron increase. Attraction of this valence electron increase. So which means the higher the effective nuclear charge across a period, the valence electrons are more and more attracted towards the nucleus, which means as you can see from this diagram, the size of the atoms have decreased. There may be slight changes or slight decrease, but the sizes of the atoms decrease. So compared to oxygen, fluorine is smaller, even though in this diagram it doesn't highlight that much. Across a period, that's the trend. So you have to remember that trend. And children, let's look at the variation of the atomic radius down the period. Now if you look at this, effective nuclear charge decrease. So based on what we discussed earlier, I hope you remember that. So we concluded that the effective nuclear charge decrease. Why? For example, if we consider lithium and sodium. So lithium has 1s2 2s1 electronic configuration, whereas sodium has 1s2 2s2 2p6 and 3s1 electronic configuration. So which means now for lithium 1s2 are the only electrons which impart the shielding effect, whereas for sodium 1s2, 2s2 and 2p6, all these electrons impart the shielding effect, or they tend to repel these 3s1 outermost electrons. So which means the charge or the attraction of this valence electron down the group decrease. So when it comes for potassium, there are more inner shell electrons, and also rubidium. So likewise, as a result of that, the effective nuclear charge decrease, or the charge felt by this valence electron towards the nucleus decrease, as it is far away and there are more inter-electronic repulsions from the inner shell electrons, and therefore the atomic radius increase. Atomic radius increase down the group. So what you need to remember, across a period, the atomic radius decrease, and down the group atomic radius increase. So you can clearly see that from this diagram itself. I hope it's clear, and you need to remember this trend, and at the exam you may be asked to compare. You may not be given the elements in their usual order. For example, you will not be given lithium, beryllium, boron, carbon. Likewise, you may be given lithium, and maybe you will be given an element like phosphorus or even chlorine. Now let me clearly tell you. So you may be given let's say lithium and sulfur and fluorine and calcium. So you will be asked to put them in the ascending order or descending order of the atomic radius. So which means you will have to find out from lithium, calcium, sulfur and fluorine which is the smallest and which is the next highest likewise. So that type of questions you can expect from this section.